Welcome to another GCBASIC tutorial for the 16F175 chip family. This is part 17 using CLC, whatever that is. Let's figure it out. So, part 17, CLC, configurable logic within the microcontroller. We're going to make something happen with no program logic. It's going to use the configurable logic in the chip. So configurable logic cells. We're going to program it, we're going to set some registers, and we're going to make some magic happen. But it's also representative of how you can take code from other places and paste it directly into GCBASIC, and it will work. Please like and subscribe this video and the channel. Subscribe to the channel. I'm in it for the likes and subscribes. So let's get straight into it. I'm assuming that you've installed everything, that you've gone through all the prerequisites. Pause it if you haven't. In reality, you just need the chip this time to be able to program it, because we're not going to see the results, but we're going to see it on the camera. In terms of what we're actually going to be using, we're actually going to push a button on port A3, and these LEDs will come on with no program logic. There is no program running at the time, but the CLC will activate the LEDs. Because the configurable logic cell allows you to implement custom logic functions within the hardware without any CPU intervention. It's as simple as that. You can make some very complicated things very, very simple. You don't need to test the switch. You don't need to test the LEDs. You can just say, in the logic of the microcontroller, do the following, and that's what we're going to do. So you can set up AND gates, OR gates, or XOR gates. You can have flip-flops, sequential logic, and then you have this concept of an input and an output. And the inputs are signals or from other peripherals or other external influences like signals from pins, and then you can create an output using the logic gates and the flip-flops. So you can generate a custom pulse width signal. I did that for a lighting system. Signal modulation, you can do that, and LEDs that control the sequences in LEDs. And it's not that hard. Now I put this diagram together because there is no other diagram like this. Because essentially you can have up to 16 inputs on, if you have 4 channels, you can have 16 inputs. And that can be internal or external. They can all be different. They can all be chosen differently. As I said, you can have AND or XOR gates, and you can combine those, and you could take sequential logic like the flip-flops and latches and put it back into as another input. Oh, it's like you can do a bit of recursion here. So what you've got is this diagram that I've drawn. You have signals, start points. They come through logic gates, through flip-flops, and then you have an output. And in this case, my input's going to be a switch, and my output's is 4 LEDs with 0 code. Because what we're going to do is using a digital logic diagram like this, we're going to create an input, we're going to use some gates, and then we're going to not the output. And it'll make sense to you in a moment, because I'm going to do the following. Put my pen on. I'm going to set the PPS of the switch as an input to here. It will come through here, and then I'm going to invert the output here. So when I push the button, LEDs will come on. How do we do that? Well, we're going to create a quick example. I'm actually going to use a microchip tool, and it's called the Microchip Standalone MCC. There's the download location for it. There's different ways of getting it. I put both of those in here. And what we're going to do, we're going to use that tool to create the logic, and then we're just going to steal that logic and put it inside of GCCode and compile it. It's like, just paste it in. Let's get started. GCCode. I'm going to take the chip range demonstrations. Don't really need to show that anymore. Shut down that terminal window and file, and I'm going to do which demonstration. It must be the CLC demonstration, so I'll just turn the filter on, Control F, .gcb, apply the filter, and where is it? Down here, 340 using CLC. Now, I think it's worth programming it so you can see the output first. Function key F5 to program it, and here is my board. Hasn't changed much, it hasn't changed at all. But essentially, I've got microcontroller, a switch on A3, and 4 LEDs down here. When I push the button, 4 LEDs come on. Now, there is no logic making this happen. I'll show you the program. Here's the program. Do loop. That's it. That's all that's in the program. So something is making it work. And what this does, we set up the PPS. We have used PPS in the past for doing serial output, setting the serial. But what this one does, it says, I'm going to use an input of a CLC, number 1, as an input on A3. And the output is on all 4. It's as simple as that. Because like if I do the following, if I comment out these 2 here, look, I'm gonna how can I prove this to you? I'm going to show you a little trick. I'm going to program it. What I've just done is turned off 2 of the LEDs just to prove that it's working, and then we're going to look at how we generate the CLC. Now, if I push the button, I get 4 LEDs. Ooh, why is that? Because we haven't reset the PPS for the whole chip. Unplug, plug it back in, power cycle it. Reprogram it. Now if I push it, I get 4 LEDs. Why do I get 4 LEDs? Resuming the video, I'm just going to show you a little trick. It's working. The reason why it didn't reset it, because it wasn't power cycling it. I had this plugged in. The USB TTL was using parasitic power. It was putting enough power into the microcontroller, so it didn't actually do a power cycle. Look, so what I did is I've commented out 2 CLCs just to prove to you it's working. So how do we come up with this PPS? We can go into PPS tool and we can do it there. However, there's a lot more to this than meets the eye, because all these registers, CLC select 0, POL 01, etc., you could spend a long time going through the data sheet trying to figure out how to connect that. And then essentially, look, down here I've got a do loop. The rest of it's the same, look. So where do I get all this from? I get it from the Microchip CLC tool. So if I've installed it, and I type in MCC Standalone, it will bring up a dialog, and we're going to walk you through how I did it and how I do it. I do it this way. I'm not kidding. There's no other way of doing it. Okay, it's the quickest way of doing it. So, File, New Standalone Configuration is what we are going to do. Now I'm going to move the screen around quite a bit here. Set up the project folder path. I'm just going to take the default. You might want to take something else. You put it where you like. I don't know. Next. I have to sort of click it. I'm going to overwrite my existing one. That's fine. And then select my device. 16F175xx. Press OK. It is now going to start up the Java backend, which takes a few moments. And it's going to take you into what's called the CLC, the configurator. It's got a lot more in here than I'm going to show you. You can do PPS in here, you can do everything in here, but you're going to have to learn it, okay? And that's the issue here. So I want to build something. So I'm going to add in, I've got lots of different things going on here. But what I actually want to do is I want to just add in CLC. So if I take the right, the left, at the moment it's device resources. It's constantly changing. And I type in the word CLC. I'll zoom in on that for you. I took the left hand here. I typed in into the device resources and CLC. And so if I just press the green button on the add CLC1, magic has happened. And if we look at the screen, the big screen here, I'll zoom out. On the right hand side, this screen has appeared. And look, down here, look, I've got that diagram we were looking at earlier on. I can zoom in and out a little bit. But let's just set up some ports, shall we? All right. We've set up a CLC. And down here, I've got a nice user interface on how to configure the CLC. And here it is, look, CLC1 on the left. It's here on the left in the packages. And I'm going to say I want an output, and I want my 4 LEDs to be the outputs. Okay, port C. My input, CLC in, that's the input. I'm going to put that on A3. We already know that because that's where it was and has been the whole lot. So I've set up the pins, the input and the outputs. It's easy. How do I set it up elsewhere? Well, you need to come into this little diagram. I will shuffle things about here so we can see it all in one go. What I'm trying to do is get it all on the screen at the same time, which is a little bit tough, but I will do my best. Here we go. I think that's good enough. So we already know that we're using CLC1, CLC in, so I'm going to connect that to that gate. Now the signal will pass through. I need to change it slightly because I need a different type of gate. I want an OR or XOR gate, and that's just the way that this particular logic works. You would put your own logic in. You can set up interrupts, the same interrupts. GCBASIC will pick up the interrupts. It will handle them. But we're not going to be using that because I want this gate here, and I want to invert my output. That is it. I set up the pins, I set up my logic. How do I generate my output? So I slide across and generate, press the generate, and it's generated the code with no warnings. I have no warnings. User output, let me just come down here to the user output. It's all successful. Look, it's all successful. It's all great. But it's all tucked it away inside of it's inside of the folder that we chose initially. So where do I find that? Well, the way I do it is I go File, New Configuration, and when it shows me the dialog here, oh, why has it done it down? I can't see the dialog because it's off the screen here. I'll do that again. I go File, Standalone Configuration, and this is the folder I selected. I just browse to that folder, and then I open that particular folder, MCC generated. I will zoom in for you. This is the folder I have selected. Yours may be different. MCC generated files, and open that in the new window. Cancel that. Shut that all down. You don't need MCC anymore. You can get rid of this now. Minimize it. There, it's gone. Now we've got the folder with the MCC generated files. If you go into CLC, source folder, I will go back up and zoom in for you so you can see that. CLC, click, click. Source, SRC, and there's a C. There's a C, piece of C. Just open it up in your favorite notepad. Look, here it is. Look, in Notepad. It's quite happy. I wish my computer wouldn't play up like that. There we go. If you look down here, initialization. You can take the whole of that code and paste that into the top of your GCBASIC code. What is it doing? It's setting up the registers. There's a lot of registers. Yes, you can do this in the data sheet. Don't. Just use this tool. There are other tools out there. Use this tool because you will never get the sequence right. So we are setting up the first CLC. So we set it to 0. We say don't invert it. And we set up a load of zeros because we didn't change the rest of the gates. And then here's our selection for the actual type of gate that we're actually running. Now, you can work through all that. Take this code, put it in GCBASIC. What else do we need? What else we need is, because we played with the port, you come back up into the system folder, into another source folder, SRC, and in here there's one called pins. Take that into your favorite editor and cut out the PPS registers. Well, look, there's the 5 we selected. There's the input, CLC IN0, which happens to be the first CLC. It's just the way they do it. And then you've got the ports. Now you can do all that in PPS tool, but your brain will just explode. Take that, paste it into the source GCBASIC program. And it's exactly what I did. That code is this code. And the code in here for the CLC, select set CLC1, you would see exactly the same words. That's what it's doing. So essentially, it's setting up the input PPS, the output PPS, and then this is the logic to connect the two in hardware, and there is no program. That's how you end up with that. The 2 running, I will recompile, put it all back in. And we'll look at the desk cam. If I push the button, 4 running because I've got them back as it was. CLC has great capabilities. You should do greater research, but takeaway here, you can write to the registers of the CLCs directly. These are registers in the microcontroller. And therefore, any register that's in a microcontroller, you can write to exactly the same, because that's all that GCBASIC does. With that, you've seen some insights into how to write to registers and how to make CLC work. Next video is we're going to look at the GCBASIC toolchain, because that slide isn't quite correct. Enjoy.